Hey guys, we're doing another example problem. So you can add this to your notes. You can start a new page of notes. It's up to you. We're just doing another example problem. Can you what? I wouldn't waste the graph paper if I was you, just because you have multiple problems to do, and if you have one sheet of graph paper, that's probably gonna need all the problems on it. All right, so this is example 2. Y equals x to the third divided by x squared plus 1 is the problem we're going to work with. All right, so first thing, what do I look for from the original equation? Asymptotes and intercepts, x-intercepts, y-intercepts. Okay, what do you guys want to look for first? X and y-intercepts. So what do we do to get the x-intercepts? Yeah, we set the function equal to 0. Our function is a fraction, so how do you make a fraction equal 0? You make the top equal 0. So to find the x-intercepts, we're going to take the top and make it equal 0. So x to the third equals 0. What happens when I solve for x? I get 0. So third root of each side, and we get x equals 0. So our x-intercept is 0, 0. How do we find the y-intercept? Yeah, we plug 0 in for all of the x's. Y equals 0 to the third over 0 squared plus 1. 0 over 1, which is 0. Okay. Which makes sense, right? Because the origin is on the x-axis and the y-axis at the same time.
So if we're setting the x to 0, how did we already get our y-intercept? Just by solving it?
Yeah, this is us getting our x-intercept by taking what y equals the fraction. So we said if you take the fraction and make the fraction equal 0, that's basically saying you just need to take the top and make the top equal 0. So that was us solving for our x-intercept. When we solve for our y-intercept, we just plug 0 in for x and see what the y-coordinate is. They happen to be the same point, which will happen anytime you have an intercept at the origin. If you have an intercept that's not at the origin, then you really would get 2 distinct answers for those. Okay. Asymptotes. Do we have any vertical asymptotes? Looking at the bottom of the function, think about if you can factor the bottom. Can you make those factors equal 0? That sort of thing. So can you factor x squared plus 1? No. Difference of squares. X squared minus 1 would factor. X squared plus 1 does not factor. Okay. Is there any way you can make the bottom of the fraction equal 0? So if you had x squared plus 1 equals 0, how would you solve that? X squared plus 1 equals 0, x squared equals negative 1. And then what would you do? Square root of negative 1, which is I, which is imaginary. Are we going to draw an imaginary answer? No, we're not. So for vertical asymptote, we're going to say none. Okay. Your degree is bigger on the top than the bottom, x to the third over x squared. Is there a horizontal asymptote?
Please pardon the interruption. Teachers, please check your emails at this time from Sharon Johnson.
Yeah, so if we look at this, if we think about our limits, right, you can find a horizontal asymptote when you look at the limit as x approaches infinity. And what happens if you look at the limit as x approaches infinity? It's bigger on top. That means it goes to infinity. That means there is not a horizontal asymptote. So if there is not a horizontal asymptote, then what is there? There's a slant. So rational functions always have one or the other. That means there's a slant. That means we have to do polynomial long division to find the slant asymptote, which is why I'm doing this example with you. Okay? So we have to do x to the third divided by x squared plus 1. So I'm going to do x to the third divided by x squared plus 1. And when you're doing Give it a second. We'll see if the lighting give it a second. There we go. All right. So when you're doing a problem like this and you're dividing it, you can't have any missing exponents on the part that is the divisor, whatever, the part that's underneath the house. So we're going to say x to the third plus 0x squared plus 0x plus 0. Technically, we're supposed to have all of those things filled in. So if you're missing any of the terms, you just put a 0 in its place. Okay. So when we do polynomial long division, we say, if I have x squared, what would I multiply it by to make it x to the third? X. And then once we have that number on top, we take that number on top and we multiply it by both of these pieces in the front. So x times x squared is x to the third. X times 1 is x. We need to line, we don't put the x right here because that's where x squareds go. We're going to put the x over here. Okay? And then we draw a line underneath and we change the signs because we're subtracting them. So we're left with 0x to the third, 0x squared, and negative x. Yeah. When you write a slant asymptote, you always have to get y equals mx plus b, because a slant asymptote is like, it's a straight line still, it's just a slanted straight line. So y equals mx plus b is how we write those. And so I already have the m times the x, my slope is 1, so mx, I already have that, but I need to get the plus b part. Okay, so I'm going to look at my x squared term because that's my next one. X squared times what gives you 0x squared? 0 plus 0. So now we have y equals mx plus b. So we don't have to do the entire division problem, we just have to do the first part. Okay. If you don't remember how to do that, you might need to look up some videos. I have videos on my website for Math 3, okay, that go over how to do that. All right, so the slant asymptote is y equals x. That's going to be one of the things that helps us graph this. Okay, we are done with the stuff for the original function. What do we do next? Derivative. We're going to do the derivative. All right, so I'm done with the original. Now I'm going to do the derivative. How do I do the derivative of x to the third over x squared plus 1? Quotient rule. So low d high, what would the derivative of the top be?
3x squared.
3x squared minus high d low, what's the derivative of the bottom? 2x divided by low squared. Okay, so we need to clean that up a little bit. What do we do?
Or distribute.
Distribute. So I have 3x squared times x squared and 3x squared times 1. 3x to the fourth plus 3x squared minus 2x to the fourth. Okay.
Would it be unhelpful for us to write x squared plus 1, x squared plus 1?
It wouldn't. So if you think through what you're about to do next, after you simplify it, you're going to say where is the derivative equal to 0 and where is the derivative undefined. And it's, you know already that you can't solve the bottom, because whether it's x squared plus 1 or x squared plus 1 squared, when you set it equal to 0, you're going to get an imaginary answer. So I would not mess with the bottom just because I know it's not going to give me anything. I'm just going to leave it. All right, so on the top, what do we have?
X to the fourth plus 3x.
X to the fourth plus 3x squared divided by x squared plus 1 squared. So we have simplified the derivative, and at this point, what do we do with the derivative? Set it equal to 0. So we want to see where the derivative itself equals 0, which is when we take the top of the fraction and set that equal to 0. We want to see where the derivative is undefined, which is when we take the bottom of the fraction and set that equal to 0. So I'm going to go ahead and write x to the fourth plus 3x squared equals 0. And I'm also going to write x squared plus 1 squared equals 0. So this is where the slope is 0, this is where the slope is undefined. How do I solve something that looks like this?
You have to factor.
You have to factor, yeah. So factor out an x squared, we have a GCF. And that leaves x squared plus 3. All right. So x squared equals 0, so that means x equals 0, so that part's good. What about x squared plus 3?
It would be plus or minus square root.
Square root of negative 3.
Square root of negative 3, which is imaginary, so we ignore it. So I'll go ahead, just because these are notes and I want to have good notes, I'm going to go ahead and show some work there. Plus minus square root of negative 3, and then I'm going to show myself not using it.
If we pursue this in college, are we gonna end up dealing with imaginary?
Not for sketching a curve, because an imaginary answer is not going to make any difference on a curve. Yeah. Because right now we're looking for our critical points to see where things are increasing and decreasing and see if they're a max or a min. And those are real things on a graph. Yeah, so imaginary answers don't make much difference for us. All right, so we're going to square root each side for this one. And we have x squared plus 1 equals 0. And then we have x squared equals negative 1. And then we know if we take the square root of that, that's no good either. So those are not going to help us. So I'm always making sure that when I write my notes out, they have a lot of detail and I'm not skipping steps, because future me is going to need present me to do a good job, right? So if in the future you need to look back at something, it helps to have all the details written down. All right, so at this point, what's the only critical number we have? 0. Okay. So 0 is what goes on our sign chart. And then what do I do with that?
Negative 1 and 1.
Okay, negative 1 and 1. Yeah, I actually don't have to plug anything in. Anyone want to tell me why you don't have to plug anything in? You have even exponents for everything. You guys see that? So it's always positive. No matter what you plug in, it's always going to be positive. A negative to the fourth is positive. A number to the second is always positive. On the bottom, we have positive. So we're just going to say it's always increasing. So should I look at that and say it's increasing from negative infinity to infinity? No. What should I say? So what's happening at 0? It's a horizontal asymptote. So it's gonna flatten out for just that moment. We have an asymptote or a slope of 0 at just that moment. So that means that it's increasing from negative infinity to 0 and 0 to infinity, but it's constant. That means it's flat at 0 exactly.
Why wouldn't you just do negative infinity to positive?
That's what I was just explaining.
Sorry.
So the reason you wouldn't say negative infinity to positive infinity is because right here at 0 you have a slope of 0.
That means we don't have any x's and min's.
Yeah, that means the graph flattens out.
Can you
Right there.
draw that?
Yeah. So it's increasing, goes horizontal, increasing.
Okay.
But that's like flat. That'd be perfectly flat right there.
Point of inflection.
Yeah. So, so you can already tell you are going to have a point of inflection at 0. Do you guys see it?
Yeah.
Okay. So for relative max and relative min, we're going to say there's none. Why are we going to say there's none? Yeah, some of you guys on your quizzes yesterday, you just made up some relative maxes and mins to make sure you had an answer. But there just wasn't any there. Yeah, it's possible to not have them. Okay. Oh, they're like, oh, shoot, that was me. That was me. All right, yeah. You won't get them back today, probably tomorrow. They're mostly graded, but not all the way graded.
Have they generally done okay?
The rules, the Rolle's theorem, actually, let me pause this real fast. So at this point, we're done with the first derivative. Now we got to work with the second derivative. So if we take the most simple version of our first derivative, that would be my recommendation when you start to do the second derivative. Take the most simplified version of your first derivative. It'll make your life easier. Don't use a factored version of it. Don't give yourself the product rule on top of the quotient rule. So like I'm going to use this version. I'm not going to use this factored version. But if you use the most simplified version, your derivative is going to be easier to find. Okay, so what do we do here? Quotient rule, so we're going to do low d high. So x squared plus 1 squared times, what's the derivative of the top?
4x squared plus 6x.
Okay, minus high d low. Actually, hold on. I forgot. I did this in the video too. Does anyone remember what I did in the video? Yeah, I brought it up. Yeah, I brought it up because it makes it a little bit easier if you do the product rule instead of the quotient rule. I forgot that I did that. I was looking at my notes because I always have notes up here just in case I brain fart. And I was like, I did not do that the same. All right, so for my first derivative, I'm going to go ahead and write x to the 4th plus 3x squared, and then x squared plus 1 to the negative 2. So I'm rewriting my first derivative as a product rule, not a quotient rule. So that is the first derivative, just rewritten. Okay. Yes, you can do the quotient rule. I think the reason that I didn't do it is because I tried it both ways, and the quotient rule was like not fun. And so I was like, do product rule, and then our lives will be a little bit easier. Okay, so second derivative. We're going to do first times the derivative of the second, which is x to the 4th plus 3x squared times, what would we get? To the negative 3, and then times 2x. Yep, that's the chain rule. Plus
X squared plus 1 to the negative 2 times 4x to the 3rd plus 6x.
Okay, so second times the derivative of the first. Okay, and at this point, what do we have to look for? Yeah, we're gonna end up. Well, we're not quite factoring it, although that's interesting. I wonder if we could factor it, but we do. We're gonna clean it up a little bit, right? Which is gonna give us some denominators. And then what are we going to do once we have those denominators? We're going to need to find a common denominator. Okay, so I'm going to clean it up a little bit. I've got a 2x and a negative 2. What does that give me? Negative 4. So I'm going to say, or negative 4x. I'm going to say negative 4x is on top. X to the 4th plus 3x squared is on top. And then the x squared plus 1 to the 3rd is on the bottom.
And because x to the 4th plus 3x squared is technically over 1, that's why we
Yep. This is technically over 1, and this is over 1, and that's over 1, and that's why all of those ended up on the top. Okay. Does it make it more visible if I turn this light on, or is it just like, hold on. Nope, give it a second. It calms down. Is that better?
I like that.
That's good.
That's better?
It's much
All right. I think I turn the light off usually when I use the calculator. Nope, I don't remember. Sometimes it just seems better with the light off. All right, how do I fix the second part?
4x to the 3rd plus 6x over.
I guess we don't really need those parentheses, though. Over.
X squared plus 1.
Okay. So I've got two fractions. The denominators are similar, but a little bit different. And so what do I need to do? Yeah, the top and the bottom by x squared plus 1. They should call this class like calculus / super duper advanced algebra. So what does the first fraction become when we distribute that negative 4x? Okay. And then it turns out we needed parentheses here after all. Okay, so how do I multiply these out? We FOIL.
Can we do the?
The box? We can do the box. If you don't like the box, go ahead and FOIL it and see if you get the same answer.
Miss Rice, this was Isaiah's good thing when you did that the
I
other
don't
day
like the box
in
either.
English. He said, Miss Rice used the box.
And I loved it. Do people make fun of you for using a box?
People have been like, what are you doing?
Yeah, I like it. Just organizes it, which is nice. Yeah, it helps. So 4x to the third times x squared.
4x to the fifth.
4x to the fifth. And then 4x cubed times 1.
4x to the
And then 6x times x squared.
6x cubed.
6x cubed. Oh, I could have put that over here. And then 6x times 1.
6x.
Okay.
Are our fractions generally going to be this pretty, like with the common denominators, where we don't have to do too much to get it?
Yeah, I'd say, like, this is actually kind of like, have you guys noticed that when this thing happens where you have to get that common denominator, it's like maybe a square root that's similar to the other square roots, or it's like a parenthesis that's similar to the other parentheses? That is generally going to be the case because of where your numbers are coming from, and that's because you're multiplying. You have the chain rule happening with the bottom, and so the inside of the chain rule shows up in multiple places, and that's what ends up creating your denominator, and that's why they're the same. Yeah. Okay, so what do we see about the top?
You can cross it for it.
Yeah, the fifths are gone, which is great, because that would have not been fun to solve for.
It's 12x cubed
Mhm.
is negative 2x.
Negative 2x cubed, okay. Plus 6x, okay.
We can factor.
So we have made that second denominator, or that second derivative as simple as we can. And so now, yeah, so now we're to the point where we can start setting it equal to 0, right? We can set the top equal to 0, and that's where we're talking about we're going to start factoring the top to solve it. When we set it equal to 0, we can set the bottom equal to 0, but we already know that's going to go nowhere. Okay, so I'll go ahead and set the top equal to 0. I'm going to write this on the other side of my page because we're going to have to use it anyway. Okay, so we're going to say the top equals 0. And so how do I factor that? And I'm going to go ahead and take out a negative with it, negative 2x. And what does that leave me with? Okay. X squared minus 3. So that's different than before. Before we had x squared plus 3, and so we couldn't get anything from it. But this time we have x squared minus 3. So it's plus or minus square root 3. So for here, I'm going to say x equals 0. For here, I'm going to say x squared equals 3. Are we okay with me saying that?
Yeah.
And then I need a square root. And so that I don't kill a duck, I'm going to put a plus minus in front of that. Did anyone kill a duck? No? I got it. I got it. No dead ducks today. All right, and then I'm going to go ahead and make my sign chart. All right, so what are some numbers that we can use to plug in?
Negative, square root 3, and positive.
But we're not going to plug those in, right? So what should we plug in? Yeah, 1 is smaller than square root of 3. And then what could we plug in outside of those? 2. All right, so I'm not going to stress plugging them into the bottom because even though this is a third, this part is squared, that's always positive. Okay? So I know that whatever happens, I'm going to have a positive on the bottom. There's 4 of those. Positive on the bottom for each of them. Positive on the bottom, positive on the bottom, positive on the bottom. Okay. So for the top, if I do -2 times -2 to the third, what's that going to end up being? So it's -2 times -8, which is positive 16. So 16 plus 6 times -2 is positive, right? 16 minus 12. Positive. Okay. So that's a plus. -2 times -1 to the third is -2 times -1. So that's positive 2. Positive 2 minus 6 is negative. Okay. If I plug in a positive 1, I have -2 times positive 1, which overall is -2. -2 plus 6, positive. Okay. And then a positive 2 would be -2 times 2 to the third. So -2 times 8. -16. -16 plus 12. Negative. Okay. So now we have our concavity. Concave up, concave down. So what's our concave up? Zero to √3. And then concave down. And okay. And do we have any points of inflection? Yes. What are the points of inflection? -√3, 0, √3. We already know what the y-coordinate is of the point that has 0 as the x-coordinate. 0. That was the x-intercept and the y-intercept. And now the point of inflection. And we predicted that, right? We knew that was a point of inflection based on our little sketch we had. Okay. What do I need to do with these x-coordinates to find their y-coordinate? Plug them into the original. So y of square root of negative square root of 3 is negative square root of 3 to the third.
That's 3 square root 3.
That's 3 square root 3. Good. But it's going to have a negative, right?
Yes.
Yes. Divided by negative square root of 3 squared plus 1.
So 3 square root 3, 4.
3 square root negative.
Yes.
Negative 3 square root 3 over 4.
Can you show me how you got -3 square root 3?
Yeah. So if we do negative square root 3 times negative square root 3 times negative square root 3, these two multiplied together would be positive square root of 9. Negative times negative is positive. Root 3 times root 3 is 9. So it would be positive square root of 9 times negative square root of 3. So that's just 3. All right, so we have negative 3 square root 3 over 4. And then for the positive version, it's going to be the same thing, but it's not going to have that negative there. So we're going to have positive 3 square root 3 over 4. Okay. Now, the good news is I talked to the science teachers and asked if we could borrow their scientific calculators on Monday and Tuesday so we could use them during the test, and the answer is most likely yes, which means that while you will not be able to use graphing calculators because I don't want you to be able to check your graphs, you will be able to use a calculator to do things like this and find decimals. Okay? So let's go ahead and get our calculators out and check to see what those decimals are so we can actually graph these points. And since we are graphing these and these are not like answers that we're leaving, I'm going to go ahead and write one decimal place. Are you listening? On the AP exam, they want 3 decimal places for every single answer. The only reason I'm writing 1 decimal place is because I'm graphing this. The point of these problems is to graph it, okay? So this is for me to have an easier job graphing. I can't graph to 3 decimal places. I am not that good with graphing by hand. All right, so we're going to graph this. We got to switch to our graph paper.
Can you order those post-its off Amazon?
You could look them up. I wouldn't be surprised. All right, I shouldn't have a lot of talking because you should be starting to get your decimals and start drawing on your graph paper. I know you guys can graph points. I'm just looking for my little graph. All right, I should not hear any talking. None at all. You are working on graphing. All right, so we have an X-intercept or a Y-intercept at 0, so we're going to go ahead and draw that. We have a slant asymptote at y equals x. So we're going to go ahead and draw that. We didn't have a max or a min. We had 2 points of inflection. The point of inflection was at negative 1.7, so left 1.7, up 1.3, to the right 1.7, down 1.3.
You're talking about the square root and stuff?
Yep.
Okay.
Yes.
Can I have a student sit in here or are you out of desks?
No, it's fine. I don't have any extra desks though. It was literally on the floor. No, yeah.
Thank you.
Yeah, you're good. All right, I graphed these backwards. Hold on. It was left 1.7, down 1.3. That was my bad. Right 1.7, up 1.3. They end up being very close to the asymptote. All right.
Is that normal?
I think this graph is just real funky, to be honest. So I don't know that this is like a normal graph necessarily. All right, it said from negative infinity to negative square root of 3, it was concave up, which means that from here to here is like an upward shape. Do you guys see that? It goes up a little bit, but it's very, very close to the asymptote, so it's kind of hard to see that. Okay, were we able to draw that? From positive square root 3 to infinity, it's concave down. So it's kind of like, so if you guys remember from the video, one of the things I said is to pay attention to symmetry. And so this is something where you're going to see a lot of symmetry happening. My grids are super tiny, which is part of why you can't see this. I'll show you guys my other drawing in a second that I did on bigger graph paper. And then it says from negative square root 3 to 0, it's concave down. So that means that it's going to be something like this. That's at least a little bit easier to see. See how it goes, like Scooby. Okay. And then it says from 0 to square root of 3, it's concave up. So I'm going to show you a better drawing.
This is so weird.
It is weird. So there's another drawing of it. You guys can see that this part right here is concave up. This part right here is concave down. Concave down, concave up. Looking at increasing and decreasing didn't really help us because it was like increasing the whole time except for at 0 where it leveled out for a little bit. Right. Okay. Were we able to get our drawings done? Okay. So if you want to check your answer, which is a great idea, we should check these. You technically don't ever need an answer key because you can just graph it on your calculator and see if your answers make sense. So when we graph it, should we graph a derivative? No, we should graph the function itself. So I hit alpha y equals so I could plug in the fraction. X to the third on top, x squared plus 1 on bottom. For my window, I don't need a lot of numbers there because this graph is pretty tiny. So I'm going to go from like -3 to 3. Okay. Now, if you want to be able to see how it is approaching the slant asymptote a little bit better, you can hit your y equals button and you can graph your slant asymptote. And then you can see it a little bit better. All right. Does that make sense? Okay. So, for the assignment you guys have,